Okay, here's the Hello World program that I did on the first video. I tried to run this on a Windows 8 laptop and it would not run. Then I tried compatibility mode for Windows 8 and it did run. Which, who wants to have programs have to run in compatibility mode? Not me. So it got me wondering, why does this thing run in compatibility mode? Why? And it's so small. What's wrong with it? So I did discover the problem, and I did fix it, and I did get it to run in Windows 8 outside of compatibility mode. And I'm going to retrace those steps here today and what I did to fix it, and that's what this video is going to be about. So the first thing is that what sucks about this is that it uses runtime function to do the work in the background, and you don't get to see what happened to print this to screen. So that kind of sucks as far as that's concerned. So what I'm gonna do is I'm gonna do it without the runtime support. So I'm gonna make a new project here. I'm gonna make the naked exe, and I'm gonna call it Hello WorldW. Okay. Before we do that, let's run that. So there it is. This is a Windows 7 computer I'm making the video on, so it runs fine on this computer. Hit enter, and the program exits. So the first line creates the console window. Second line prints hello world. Third line gives you a little blinking cursor so that the window doesn't disappear really fast, and then the program exits. So that's what those three lines do. We're going to go ahead and close that now, and we're going to go to the naked one, and we're going to try to do the same program without the runtime support. So, and I'm doing it on a video, and I have no idea. I'm going to probably fiddle fart through this a little bit, and I guess it is what it is. So first, to open the console window, we got to run a Windows API function call. I'm going to look for alloc console. And it doesn't take any parameters. Okay, that should open the console window for us. Now what I want to do is I just want to maybe do a print or a println of hello world. But the println doesn't exist. So we're going to go down here and we're going to make a function called Println, and it's going to accept a byref not stack db parameter called someText. Okay, so why did I type all that? Essentially, I'm looking for the address of a string. And a string is, db is for byte. A string is a kind of an array of bytes, is what it is. So that's what the db is going to represent. The byref means force it to be the address of the byte. By default, this compiler is made so that these db data types, all the assembly data types, pass by value. So I don't want the value of the first character, which is capital H. I want the address of the H, and that's what the byref is going to force. Now the not stack, that's I kind of built the compiler so that it does not do stack buffers. They just don't exist. So this parameter forces you to give it a non-stack buffer. It won't accept any if the DB variable is made on the stack, like it's a local, this function won't accept it. So you have to send it something that was not created on the stack. And there's a reason for that, and we'll get to it, I think. So first thing we want to do is we have to get a handle for our console window. So I'm going to say invoke the 64 API again, code, let's look for, I think it's get std handle. So now that has a parameter, which is I think it's called a constant, but I call it an immediate. It's basically a number. So what we're looking for is win64.immediates dot, I think it's std output handle. Okay, so that function will return our output handle, which we don't have a variable for that. Let's go ahead and make one. I can type local dim or var. It doesn't matter what I type there. Let's just make it a long pointer. We'll call it H console output. Okay. So when this function returns, the return value that it gives us is in the RAX register. So we have to move into our variable H console output what's in RAX. So those two together work together as like one line. Okay. Yeah, let's just kind of jump down here. Let's see what happens. Let's try to invoke this function that does the printing. So I think it's called write console. I think it's write console A, but it's kind of an alias to write console. So that is essentially, oops, that's our function. Not sure, but we'll find out. So the first argument it wants is H console output, a long pointer. Well, we have that. H console output. Boy, I don't like that message popping up. It kind of scared me. Let's get some real estate here on the screen. Okay. Lost my IntelliSense. Okay, so when I was trying to clear my IntelliSense from that little glitcheroo I had, I hit escape, and I guess that stops my video. So I've got it restarted here. I'm going to try to pick up from where I left off. I got to try not to hit the escape key when I'm doing this, which is kind of hard because that's how it, like right now, that's what'll clear my IntelliSense, but I can also clear it by clicking elsewhere. So anytime I hit escape, the video is going to stop. Anyway, here we go. Let's just start this over. So LP buffer, that's an address of a string. Okay. So we have our parameter sumText, and it's passed by ref. And here is our compiler support. We have address. Now, you see that quantity and quantity used? That's only there because it allows it to be a buffer. It's because of that not stack keyword. If that variable was on the stack, it wouldn't be allowed to be a buffer, and it wouldn't have a quantity and quantity used. So that's kind of where the not stack helps us. So there's address. comma. So number of characters to write. Okay. Well, let's try some text dot quantity used. Okay, so I already know that's going to be a little bit of a problem because it wants a long, and my quantity used variable is 8 bytes. So it's going to be a little upset. Oops. So there's a couple ways around this. There's more than one way to skin a cat, but let's just try this. I'm going to declare a variable that's actually a register, an 8-byte register, and I'm going to call it I don't know, let's call it quantity used. Oops. So then down here, I want to move into quantity used, the sum text dot quantity used. So now down here, I've got this. I'm back to number of characters to write, and it's a long. I can put a register in there, even a register alias, quantity used, but I still have the same problem. It's an 8-byte register. What I have is the ability now to select it down to the D portion of the register, which B is 1 byte, D is 4 bytes, Q is 8 bytes. I almost forget what W in size does. I guess W would be 2. And size might be the number 8, maybe. Not sure. Anyway, let's select D and onward and upward. Number of characters written. It wants a long. Okay. So we got to go back up here to our locals. Let's make another local. Number of characters written. Okay, that's going to be a return from the function, so we don't need to put anything in there. Characters written. Okay, anything left? All right, LP reserved. All right, so if I remember right, this is one of these parameters that we're not going to use, and I don't know what it's for, but we've got to put something in there. And it wants a bival long pointer, which is the value written in a variable, or it wants a 0. Let's put it that way. Well, it doesn't actually. It wants an address. But I'm going to set it a 0. What's called a null pointer. It's I think I could just type a 0 in here, but I'm not sure if I can or not. I'm not sure if it's going to get upset if we type a 0 in there. So normally what I do is I have a variable called null pointer pre-made, and I'm going to use that just because I know that that's something that works. I'm going to have this declared up here. Normally this is, it's part of my runtime. But I'm going to have a private variable up here. Sorry, let's indent that a little bit. I'm going to have a private variable up here. It's going to be an 8-byte variable called null pointer. I'm going to initialize it to 0. So what it is, it's a variable that has a address in program space that the value that it contains is a 0. We're going to send that into the function of write console, and I believe that's going to not upset it. That's my goal, not to upset the Windows API today. Okay. I kind of think that might be good. We're gonna test this, see if what we got's okay. We do need to have, before we test it, we got to have some way to stop the program at the end. And I don't want to mess with the readlin, because the reason I didn't want to do the readlin is because I was trying to troubleshoot why this Windows 8 laptop was in compatibility mode, and I didn't want more variables involved. I want to stay away from as many API functions as possible. So I kind of just didn't want to, and just retracing my steps I did a few weeks ago. I didn't want to use the readlin API. I just wanted to do something else that would keep the window open. So what I did was I made a kind of a delay function that would just kind of wait 4,000 milliseconds. Whether you hit a key or not, it's just going to wait 4,000 milliseconds and then exit. So of course we got to write the delay function before we can test. And what we'll do is we'll receive a DQ, which is an 8-byte parameter, and we'll maybe call it amount in milliseconds. Okay. So we have at our disposal, thankful to the fabulous Windows API, a function I found. This may not be the best function, but it's a function I found called get tick count 64. And I think that's the number of milliseconds since Bill Gates earned his first $1 million. Oh, I'm just kidding. Number of milliseconds, I think, maybe since the computer rebooted. Or something like that. But every time you call that function, it's a different number. It keeps growing. And we need to make a variable here. I'm going to make another DQ. I like DQs. I try to stay away from DDs, 4-byte variables, and try to make as many things 8-byte variables as I can, just because it just seems to make things simpler. I mean, I figure it's a 64-bit machine. It's moving 64 bits just as easy. I'm just going to use the 8-byte variables. Maybe it's not a great idea, but that's kind of how I do it. So now after this function returns, I'm going to move into my start time variable, REX. So the return is an REX, and we're going to save it on our stack variable called start time. Now, this is going to be a loop. So my loops work on indentations. And I don't know if this really do anything. I'm going to throw some no-ops in here. I doubt it's going to slow things down very much. Sometimes I don't do things that aren't necessary, and a no-op doesn't do anything. It just takes up, it's just an instruction the CPU has to process to do nothing, just to take time off the clock, I guess. All right, so now I'm going to invoke the get tick count 64 function again. This time it's inside of a loop. And what I need to do, so REX right now has the return of this function. And start time Look at that. Star time. Bet everybody saw that except for me. Well, that wasn't obvious. It was black lettering, not colored, and I just went right over it. So that's slick. So anyway, REX has the new time. Start time's the old time. We want to make the loop keep running until we hit amount in milliseconds. So what I'm going to do is I'm going to subtract from REX the start time. The answer will be put into REX. So there's that little joy. Don't have my cursor back. Thanks for the interruption. So I'm working on the end of my loop here, and what you need to do is you need to do a mathematical operation to do a jump. So my mathematical operation will be take REX, which is the difference in our times, which is the amount of time that we've been delaying, and subtract from it the amount of time we want to delay, the amount in milliseconds. And that should be a number of when they're equal, we want to exit the loop. When it's less than, that means we still want to stay in the loop. So we want jump less than. That's what I'm thinking we're going to need here. So this jump will have logic that will jump all the indented lines and land right there. And then it'll go no op, no op, no op, no op, no op, no op, no op. And it'll get another tick count. Take the tick count, subtract the start time. Do a comparison of these two, which is a subtraction. So take our current time minus the amount of... Sorry. Do the subtraction. So you're going to take the current time minus the start time, which is the amount of time we've delayed so far. And that'll be an REX. Take the amount of time we delayed so far and subtract it from the amount we want to delay. And if we're not there yet, it's less than 0, and that's a jump. So we're going to keep delaying until we have delayed the amount in milliseconds that we want. And that's kind of what we're going to go for. That's our delay. So I think we have a program that could run to start us off. Let's go for a view. Let's get our Project Explorer back here. And let's create the exe. Undefined symbol, amount in milliseconds. Okay. Amount in milliseconds. How could that be an undefined symbol? Oh, great. Isn't it? This is why I don't like doing live coding in a video of... It colored it. It colored it. It colored it. Oh, I got a parenthesis there. Okay, so it gave me an error message, even though it wasn't the right error message. I never said this was a perfect compiler. It's, by the way, it's a pre 1.0. It works great, but it's got a lot of work to go. Let's try it again here. Okay, it kind of did it quick and didn't say done. Thank you. Let's run it. 2, 3, 4, end. Okay. Now that is kind of the same program that the other one, kind of similar to the first program that will not run on a Windows 8 laptop. So what we need is something that will run on a Windows 8 laptop. So I did a little process of elimination and kind of commented things out, and I figured out that it seems like the problem is this write console function. Apparently if you use an API function that maybe doesn't exist in Windows 8, it wants you to be in compatibility mode with Windows 7. So I didn't know that they removed old functions from their kernel. I had no idea really what compatibility mode was. The documentation doesn't really tell you a lot except repeats itself on what compatibility mode is. It's a program that's not compatible. Okay. So I did a little process of elimination, and it didn't like that function on that laptop. And I can't prove it because I'm on a Windows 7 machine. You just have to trust me on that. So what I figured is that, there's this big push in the world to be worldwide, and that the UTF-16 is the string format that the operating systems are moving to, and that maybe it needed a write console W function, which is for UTF-16s. So I started on this mission to make a UTF-16. Now my compiler doesn't have support for UTF-16, so I just wanted to kind of do a proof of concept and prove that that was the problem. So I thought to myself, I need a way to convert my string buffer into a UTF-16. And it doesn't have to work for Japanese or Russian or Chinese letters. I just need it to work for my simple American letters, English letters. And so what we're going to do is we're going to need a function that's going to convert a string to UTF-16. Not a function. We're going to look for a function. And I'm going to call it convert ANSI. I call it ANSI because I think that's what it's called. Maybe I'm wrong. To UTF-16. Now, this will only work if the buffer is English letters, by the way. So this won't make it to the runtime. This is just here for this video. So what I need is the function to take two buffers. One would be the destination buffer, and one would be the source buffer. I just want to take the source, convert it, return the destination. So what I want is a by ref, not stack, db destination buffer. God, I hate that. Why is that popping a message up at me? I don't know. Gonna have to fix that because that scares me every time. Wow. What am I doing to upset you today? Don't know. Please don't yell at me. Oh, thank you. We're just going to continue here and just forget what you saw the last 15 seconds. We're going to this a by ref not stack db source. Okay. Now, in order to convert this, it's actually, I'm not going to do it the hard way. I'm not going to deal with if they're Russian characters or anything like that, because this is the cheap and dirty one that won't make it to a runtime. All I need to do is take the first letter, the first digit, letter, digit, character, whatever you want to call it, and then put a 0 after it. And then take the next digit, write it out, and then put a 0 after it. So it's got to be, H0, L0, L0, R0, D0. It's just got to put a 0 in between each character. That's all we're going to do here, and that's going to be our makeshift UTF-16 conversion. So I'm going to use a register here. I'm going to call it offset. And I'll initialize it to 0. So let's go down here. So let's see. We'll be in a loop of some sort. I don't know yet, but I know it's going to be in a loop. And we got to start pulling characters from the source. So, and I think I'm going to accumulate them in the AL register. AL is 1 byte register. So I need to do an address calculation of where I want to pull this from. and I want to pull it from the source dot address plus offset. Yeah, bracket. Okay, so that should pull the first character off the source. Now I want to write that out to the destination. I do need to... That DB may or may not be optional. I just put it in there. You know what? It's optional. I don't have to have that there. So in the destination, I'm going to have des.address plus... Okay, so this may not be obvious at front here, but I'm going to do 2 times the offset. Comma AL. So first of all, the reason I don't need that DB there is because this is a 1-byte register, and that will force the force it to be a 1-byte write into memory. So I don't need to have that DB there. Second of all, 2 times offset. So offset starts at 0. The first character's offset 0. And 2 times 0 is 0. So the first character will write in the first spot on the destination. Just follow me here. We'll get with this. Now I want to write another character at the destination. This time I do need the DB. And I'm going to do the des.address again. Plus 2 times the offset again. This time I do a plus 1. So, and what I'm moving into there is the 0. So what that's going to do is it's going to, 1 character past where you just were, write the 0, which is what we want. Now, if I do inc offset, that makes offset increase by 1. And now I need to kind of work on this loop here. So we need to, this is where you need to know how long the string is. So we have source dot quantity used. Again, because we have that not stack keyword in there, it will allow us to assume it could be a buffer. We're going to take the size of the string minus the offset. Now, the offset starts at 0. So if the size of the string is 1, offset's 0. So you got to think to yourself, you know, what kind of jump do I need to get it to keep going? So when it's at the end, like, okay, let's just say it is 1 byte long, and offset equals 0. So now you're at the point where you're done. You're done in the first iteration. So you don't want the jump to happen if it's 1 minus 0. 1 minus 0 is a positive number. Gotta hate these jumps. They mess with my head. So you want it to jump. Let's say it that way. You want it to jump if it's, let's say don't want to jump. I don't know. Let's say you want it to jump. You want it to jump if it's 0 or greater. There you go. You don't want it to jump if it's less than. Let's go with that. See what happens. JGE is 0 or greater. That'll jump up to this line. And that line will read in offset with m equal to 1, which is the next character of our source. Put it in AL. And then we're going to, now 2 times 1 is 2. So that'll move it into the destination address plus 2, which is actually the third position out, which is where we want it to be, and that will move that character to there. And then now we go one past that is our 0. So now we've read in 2 characters and we've written out 4. I hope you're following me here. It can be a little confusing. Now we're going to ink our offset again, and hopefully we got our jump right, and it's going to just keep repeating, and hopefully it'll end when we hit the length of the source. It's all hope. Okay, so there is a little extra thing we got to deal here. So the destination has stuff copied into it, but it also has its own quantity used property that starts out at 0. So we need to write into that property and update that property of how many bytes the destination now has. So that's kind of something that should have been done. We got to deal with. So let's move into the destination dot quantity used. Let's do new quantity. New quantity is a variable we don't have yet, but we need a new quantity variable. Let's put it that way. So let's make another variable. Let's make it a register again, called new quantity. Start out 0. So sorry, we don't need that space. Where would we put the new quantity in? Well, let's see here. When we come out here, the offset should be equal to the quantity used. So let's just start by this. Let's move new quantity, comma, offset. Okay, and but we doubled it. We literally doubled the source. So we need to multiply this by 2. And there's an easy way in assembly to multiply by 2. It's with the shift left. If you shift all the bits left on new quantity, 1 digit, it's the same as multiplying by 2. Let's just say multiply 2. Let's just do multiply by 2. All right. So that should update our new quantity. And we didn't need the new quantity variable, I guess. We could have used the offset and shifted it, whatever. Good enough. We're going to call it good. All right. There's that function. Convert ANSI to UTF. So let's go up here. Let's do an invoke. Convert ANSI to UTF-16. And we don't have a destination buffer. We'll have to make one. Let's call it my buffer. I'll make that in a minute. Yeah. Did I mention I do not like those error messages popping up when I'm typing my functions? That's kind of a new little feature that put itself in there. That happens sometimes. Then I got to get them back out. So let's see. We want. Oh, it's really persistent on that. Our source. Okay, we can. I do have compiler support for doing this. You may have noticed. So if I type that in there like that, the compiler will assemble that together for me nicely, and so it'll run in the function, giving the length quantity used property and the quantity property, and it's a happy, happy, joy, joy world there. Let's make a private variable here. It's going to be a db variable. I'm going to call it. Okay, so it's not just a db variable, it's a buffer. I'm making a buffer. This won't be on the stack, it's going to be in program space. And I'm just going to, this is where I just kind of make something up that's hopefully big enough. I think 100 hex bytes should be enough, especially for our example here. And I'm going to call it my buffer. Okay, so now that turned black. Oh, convert and see. All right. All right, now this Println, that's not going to work. We want the right console W version. So we will try the W version. So let's see what we got here. Console output, that's all right. Address of a buffer, that's all right. Number of characters to write, it's still long. All right, we're doing good so far. I'm going to get my screen real estate back here. Number of characters written, long. Fantastic. So the parameters are all the same. But there is a problem, and I found this out the hard way, and what it is it's a problem with quantity used. So remember we multiplied that by 2 because we had those zeros in there. Well, this function, even though there's 2 bytes per character, it wants the number of characters, not the number of bytes. So I need to do a shift right on quantity used. 1 bit again, basically divide by 2 now. So that's really awkward, and that's no good. And I think that's what it's going to take to get this thing to run. Ultimately, when I try to make compiler support and runtime functions, that won't be something anyone has to worry about. I'll have to figure out how to make that kind of not something you got to worry about. So let's kind of take a look here. We're going to alloc the console. I'm going to try to convert Hello World to my buffer version, which is a UTF-16 version. We're going to do a Println with our new right console W function, and then we're going to delay it 4 seconds, and yeah, let's give it a shot here. So, whoops, let's get the Project Explorer back up here. Let's create the exe and let's run it. And I get question mark, question mark, question mark, question mark. Okay. So, another reason why I don't like making videos while I'm coding, because things don't always work out right. And sometimes these aren't so easy to find. So why did I get a series of question marks, not hello world? That is a good question. Alright, so here's the debugger, and by the way, I did not want to do this on this video. I just wanted to write it out and run it and it work, because a week or so ago I had this working. But real world assembly, things just don't always work, and the compiler's at a point now where it can't really do debugging within itself. You have to use a debugger, which is horrible, I know, but it's my world. Let's just do this. Okay, so here's the exe we just created. Now, here's kind of a side point. Notice that it's 5K versus this is extremely small, by the way. versus the original Hello World, which is 24K. Now the original Hello World has runtime support, and this is the runtime, but the runtime is 175K. But the Hello World is a standalone EXE, which means even though it's using this runtime during the compiling, it's not using it when it runs. And I might prove that here at the end. It's standalone. You could move that exe anywhere and it'd still run, because what the compiler did is it went through this DLL and pulled out what it needed for this exe to be standalone and copied it in there. And that's that. Okay, so here's the start. Outlook console. Ta-da! Let's get that out of our way. Okay, now this jump here, this is kind of my compiler support for Hello World. What this essentially is I used to call it like a bubble, a data bubble, where there's actually data in there and the CPU is just going to jump over the data. It won't ever execute what's in that. And you can see the red line shows it's going to jump down here. Now this compiler or this debugger is confused and upset by what I've done, and it doesn't have the instructions right. But don't worry, it'll fix it here in a second. So it's not really that. But what the data is in here is 0B, it's 8 bytes. This is my 8-byte value of the quantity of the buffer. And B is the length of Hello World. And I took off the null character at the end, and I may end up adding in the future. I don't know. I don't really need the null character at the end anymore. But anyway. So there's 1, 2, 3, 4, 5, 6, 7, 8. Here's the next 8-byte number. This is quantity used. 1, 2, 3, 4, 5, 6, 7, 8. So it's the buffer is 8 bytes long, and it's using all 8 bytes. And that is Hello World. So down here is HELLOWRLD, and I believe 6C is where the real instruction should start. But like I said, the debugger is confused. So if I hit F8, I was wrong, it wasn't 6C, but I was close. So here's the real instruction. Load RDX. So RDX pulls in Hello World. That's from the data bubble we just jumped. Our CX is going to be 14220. That's our program space address of my buffer. Okay, so I don't know why it put Hello WorldW on there. Oh, that's the name of the exe. Alright, that's why I did it. They're all Hello WorldW. So let's go into that one. I'll hit F7 and let's watch this. So first thing it does is save the parameters onto the stack. R10 and R11 are two variables. I believe it's offset new quantity. RSIs can be kind of used as a temporary register for making this stuff happen. So RSI gets loaded with the buffer Hello World 12020, which is our source buffer. Now we're going to move into the AL register, the letter H. And there it is up there, the letter H. And now we're going to load RSI again. So we loaded RSI now with the destination buffer. And now we're going to put AL into the destination buffer. So this debugger doesn't show us yet what's in there. We're just going to have to kind of trust it. And after it gets 2 or 3 characters in there, it's going to put it on the screen. So the next thing to do is it's going to also the debugger has us way down here, which is a little annoying. I always got to keep moving us up. Other than that, I love the debugger. I don't know how to use half of it, but I do love it. This is the line where we put 0 into the last address plus 1. That's our 0. And now we're going to increment R10. Okay, so now that's our offset of 1. So now we're going to load RSI with I believe the source buffer, and we're going to look at RSI minus 8, which is the address of where the quantity used hidden variable is at. We're going to compare it to R10. That's where it's so it's going to be like a subtraction. Subtract the quantity used on the source minus the offset. And now here's the JGE, which I'm not exactly sure that's correct still. But it did jump. We're gonna just watch it, and we're gonna go through the loop again. So I'm gonna go a little quicker here. You can watch up here as we go through, and watch R10 as we go through. We know that hello world is B. Its length is B in hex, and HELLO. By the way, our destination buffer finally revealed itself. That L is, I think that's kind of syntax showing that it's UTF-16. So it's really H0, E0, L0, L0. Let's go through here a little more. There's the space. There's the W. There's the O, R, L, D. Okay, so right now the offset is A. We ink it, and now it's B. Now we're at the end of the loop here. Now we're going to do a compare, and looky there, we did not exit the loop. So I kind of fizzle-brained together, and I should have been thinking a little more. JGE, I believe we probably want is JG, not JGE. So I think that's probably our first mistake. There may be more. Let's go back. Let's quit this then. Let's go back over. Okay, so here was the JGE. So let's kind of do this. I think I just rushed through the video because I'm nervous I'm making a video, but I need to just think through this a little carefully here. So since that ink is there, we hit it to be B. You take the quantity used as B. B minus B is 0. Therefore, 0 is equal to 0, and we don't want it to jump. Let's just go with that. Let's take the E off there. So let's just go ahead and recompile and run that and see what we get. Series of question marks. So it's not our only problem. Let's go back to the debugger. Okay, we're back here again. Let's open that up. Let's get to that point. Here we go to Outlook, the console. Let's drag that off the screen. And let's go. We'll jump over our hello world buffer. And there's our conversion function. I'm not going to go into that one because I kind of think we got that good. I'm going to jump right over it. Okay, so I see, I think that's right. Not 100% sure, but I think that's right. I'm just trying to save a little time here. This video's getting already too long. So now what we're going to do is we got our string ready, and now we're going to jump another string. Well, why would we jump another string if we already have our string ready? What other string? There's only one. Hold on a second. Okay, let's go up here. I see the problem. So, okay, I do have to say that I kind of get nervous making these videos, and I decided to drink a beer, and I'm my second beer here, and I seem to be a little more relaxed making videos, but I seem to be making more mistakes than normal. So what I did here is I did convert Hello World to a UTF-16, but on the Println, I went ahead and printed a whole brand new Hello World again. So that, I believe that's our problem. What we need is to put my buffer in there. I believe that should pass through there. So let's try that. Of course, it's a little annoying. It won't open it if I've got the debugger holding it open, and it does. It has it open here. So I am just really fumbling through this. Okay, so let's go again. Well, it compiled. That's good. And it ran. Wow. And it goes 4 seconds and ends. Okay, well, that was not as smooth as I thought, but there it is. So that is the version that did run on Windows 8. It had to be, essentially I used the right console A function, and apparently in Windows 8 they removed that from the code base, and you have to run the compatibility mode if you use those ANSI functions. And there's probably a lot more functions that might force you in compatibility mode, and I don't know what it is. But the good news is the format of my EXE is good. That wasn't the problem. It was just which API functions I'm using, which creates kind of a big problem for me. I need to get this all figured out, and I want to make software that's compatible with the newest operating systems. I'm gonna have to rework my database of functions to be just the new ones, just the one that work on Windows 11 or the most recent version. And that's what I'll have to be working on. So this is what I had to go through to realize that. And then, by the way, I do have a Windows 10 machine I tried to run this on, and both of them ran with no problem, no compatibility mode. So, but a Windows 8 did not run the first one, unless, and it wouldn't even tell me why. It just ran and nothing happened until I went to compatibility mode and set it up. But then Windows 10 just ran it. So I don't know what's going on at Microsoft. You know, I guess it is what it is. Just the point of the whole video is that this compatibility mode seems to be using API functions that are not in their current code base. That's kind of where I'm at. So, oh yeah, one last thing. So over here is my working folder. There's the Hello World that's 24K that used runtime support. And there's the runtime DLL that it used, but I had said earlier that it's a standalone EXE. It doesn't actually use that after it's compiled. It pulls what it needs from the runtime and copies it into itself. And to prove that, I'm going to change the file name here so that it won't be found, and run this. So you see it runs by itself without that runtime. And that's that. But it needs that when it compiles. There you go. Well, there we go. That's all I got for today. Thanks for watching. I hope you enjoyed it a little bit. If you like these videos at all, making on assembly, I'd appreciate a like and subscribe. Might encourage me to keep making more. I'm not getting a lot of followers because it's kind of a dark art. I kind of enjoy it. As long as I got people that enjoy it with me as well, I'll probably keep making the videos. So, thanks.